Totally okay. Alright, well, hello everybody, I'm Gwen. I am a Unity developer and I've been making games in Unity for 5 years. So today I'm going to be giving you a bit of an introduction to what is my engine of choice and what you may want to consider for yourself. And this is the QR code for the Discord. I assume most of you are in it, but if you're not, it's right there. And the plan for today is we're going to be learning the basics of the Unity engine and why you may want to use it. This is mostly going to be high-level concepts, so I'm going to be explaining what you basically need to know about how does this engine work. So why you may want to use it is that it has very broad applications. It's been around since 2005, and tens of thousands of games have been made in it. 5,000 just in 2024 have been uploaded to Steam. It's a really versatile, flexible, and powerful engine that can be used to make basically any kind of game that you want with any kind of team or experience level. Whether that be AAA, indie, completely by yourself, or maybe you have a lot of money behind you. Unity can support all of these different levels of development. It's also really good for beginners. It's basically unmatched when it comes to getting started in game development, whether that be just using Unity for the first time or making games at all for the first time. Any game that you may have an idea for, it probably already has a tutorial for it because of how long it's been around and how large the community is. And the visual editor is very clear, it's easy to understand, everything is laid out in a way that just makes sense. And games can also be built for any platform. Whenever you're building your game, which you may do in other engines as well, you are able to target for certain kinds of operating systems. You can build for Windows, Mac, Linux, PlayStation, Xbox, Nintendo Switch, anything of that variety. And here is a little list of games that you might know that might have been made in Unity and you might not have known about it. You have Pokemon Go, Hollow Knight, Among Us, Cuphead, Subnautica, Genshin Impact, Call of Duty Mobile, Lethal Company, Beat Saber, Escape from Tarkov, Phasmophobia, Ultra Kill, Risk of Rain 2, Rust, 7 Days to Die, RimWorld, Bloons TD 6, and Firewatch. I didn't even know some of those were made in Unity until I was researching this. So for the first major concept of the Unity engine itself, we're going to be going over game objects. You can think of game objects as anything that represents a thing in your game. So every single Unity game is comprised entirely of game objects. Every level in Unity is called a scene, and every scene has a hierarchy of game objects that can either they can be parented to each other, but they can also just be within the scene. Anything that exists in your game is going to be a game object. Now, what they do specifically is technically nothing. They are empty containers, which you can fill with things called components, and those components are the things that describe what game objects actually do. You can think of a game object is a noun, and a component is an adjective. And some uses for game objects is they do anything and everything within a Unity scene. Some examples is your player is going to be a game object. The actual set, so your map, your level, that's going to be a game object. Items within your level are going to be game objects. Enemies, game objects. The UI of the game, also game objects. The camera is a game object. Everything in a Unity game is a game object. Do I have any questions? So now we'll specifically be going over what is a component. I mentioned that you can think of game objects as nouns and components as adjectives, and that rings true because a game object is merely something that is described by its components. It's the way that code can interact with the engine. So Unity has this thing called the inspector, and whenever you click on something within your scene, you will get an inspector of what components are attached to that game object. And whenever you see that, you'll also see that there are a bunch of exposed variables in those components, and you have completely free range to edit those. So when you edit them on the inspector, that will be edited for your actual code. And that inspector on the left is actually the inspector of a player that I was making for a game that I made months ago. That's an actual player game object with a player controller. And you can see there are some, it'd be easier if we had these big screens, but you can see there are some numbers exposed on that top component. Those are things that actually control the speed of the player. So you have acceleration, max speed, like turn sensitivity, stuff like that. Those are all things that are exposed in the inspector, and you can change on a dime, and it'll change how your code works. So Unity also has built-in components, and they come with basic functionality to basically get your game moving. And stuff like some basic components for Unity are going to be like the camera is a component. You'll have pathfinding agents, which are components. An audio source is a component, audio listener as well. And there's also an animator, which is the component that will control your character animations for character rigs and such. But definitely the most important part of the system is that you can write your own components, and that's basically the main interface by which your code is going to actually interact with the engine. Anybody like further elaboration on any of these points?
Does the specific order inside of the game object affect like how the components operate?
No, it doesn't. It's basically just laid out to however you think is like the most organized. Like I typically put custom components at the top and Unity components at the bottom. That's what I do. You don't have to do that. It's completely just aesthetic. You can also collapse them. What's up?
So when you said changing the variables or changing numbers changes the code, is there like a separate, I guess, like tab or area where you actually can physically look at the code? And
Yes.
it changes that?
Not exactly. So think of it as, I'm going to assume that most of you are already familiar with programming. You can think of it as you can declare a public variable on a class, and that class is going to be a component. And you can give it a default value, or you could just not give it a default value. It'll just default to whatever that type's default is. And whenever you look at it in the inspector, you will see whatever its default value is, but you can change that to something else. So if I had a variable called public int max health, and I set it to, by default, integers are going to be 0, because that's the default value for an integer. So when I look at it in the inspector, it'll say 0. But in the inspector, I can change it to like 50 or 100 or whatever I need it to be. And then whenever the game is running, it will use those values that I set in the inspector. So you don't need to edit it in code. You don't need to define any variables in code. You can do it all in the inspector. You can just define the variable and then set the value in the inspector, change it however you want to. Like for that movement script on that player, there is a acceleration value, and in my code, I just have public float acceleration. Didn't assign a value to it, but in the inspector, I did assign a value to it. And if I was testing and I didn't like how it felt, then I could just change it in the inspector. I could change it while the game is running, just to see, okay, does this feel better? Let's find a sweet spot. And that's what it's really useful for, is you can fine tune without having to touch your code. Do we have any other questions about components? All right. So as far as languages for your code within Unity, Unity's backend, so the core, the rendering, stuff like that, that's all in C++, but you're not going to interact with any of that stuff. The standardized language for scripting components is in C#. And if you've never used C#, it's a fast, high-level programming language with syntax similar to Java. It's type-safe, object-oriented, and very versatile. It's very good for scripting within Unity. It's also my language of choice. I just like its syntax. There are two fundamental types that you'll be working with and extending whenever you are writing code within Unity: monobehavior and scriptable object. And I'm assuming that most people understand the concept of polymorphism. If you don't, then these are basically just classes that the Unity developers already wrote and you can extend. So monobehavior is basically the class, these are going to be the class that you inherit from the most while writing code in Unity, because these are what components are. Whenever you're making a component, your class inherits from monobehavior. So it's a base class which all components derive from. Whenever you create a script within your Unity project, it'll automatically inherit that script from monobehavior, just so it's completely ready to go and you can throw it onto a game object immediately. Even though that is the most common though, I still thought it would be good to mention scriptable objects because they're very useful, though a little bit I feel like people overlook them a lot, but they are very useful. They're kind of like components, but instead of attaching them to game objects, you basically store them as files within your project. So it works the same way in the inspector that it would for a component, where you can edit all the variables for that file. You can see all of them that you decided to make public or decided to serialize within the inspector, and you can, instead of attaching them to components, you save them to your files. So an example of what you might use a scriptable object for is if you have I have a game where a lot of the game's content is mini games that need to be loaded in real time. The way that I tell Unity what to load is I have a bunch of scriptable objects that define what those mini games are, whether I've unlocked them, what the scene name is, and whether I should include them in the build. So whenever I create a scriptable object of that type, then I can go in my project files and I can change the variables on that just right then, right there. So instead of going to some C# script that has like a long list of game names that I want to be available, I just have a bunch of objects that tell the engine what I want to load and how I want to load it. And the last major concept that I wanted to go over would be messages, because these are also very important to the actual workflow of Unity. Unity messages are basically something that your code receives whenever something happens within the engine. So some basic examples of like Unity messages would be, there's a message called awake, and whenever awake is called, so any code that you have written in awake is going to run whenever the script is actually loaded. So whenever your scene is loading and your game objects are loading and your scripts are loading, awake gets called. So you might have some sort of application that you want to be done right before the game actually starts as it's loading. That's something you would use awake for. You also have start, which is similar and sometimes interchangeable with awake, but it's basically called after the game is loaded, but right before the game actually starts. So before it draws the first frame, start is called. And you can see that little code snippet I wrote in the top right. It says private void start. That's what a Unity message looks like. And whenever I actually start my game, then to the debug log of Unity, I will get a little message that says the game started, because that's what I told it to print. Another one which you're going to be using basically all the time is update. And update is a message that's sent out to all scripts every single frame update. So that's why it's called update. And that one's a little bit tricky, because if you're putting expensive code in update, like stuff that takes a while to run, you're running it every frame, so you need to be pretty conservative with your use of update. But if you're using it for something like checking a player position, or waiting for player input and checking that, or perhaps movement and physics calculations, that's something you might want to use update for. And then onDestroy is this gets called on a game object whenever that game object is deleted. So if you have an enemy game object and you kill that game object and you decide in your code that whenever you do that, then the enemy should be destroyed, then onDestroy will be called, and you can, whatever you want to use that for, you can use it for. You may want to, whenever an object is called onDestroy, maybe you have a long list of entities stored somewhere, maybe you want to remove that game object from that list because it won't exist anymore, and you don't want to get a null reference. There are also other basic Unity messages, like on collider enter, on trigger enter, on application start, on application quit, stuff like that. But those four are really the basic ones that I think you'll probably be using a lot. And the other ones are helpful, but we're getting into more niche like applications with those. You can also actually write your own custom messages, and this is almost the same as like calling a function, except instead of actually like triggering that function and passing it parameters, you basically tell a Unity game object like there is a function by this name on this object, call it, or maybe check and see if there is one and then call it, and it will call it like it is a Unity message like any of the other ones. You can pass one parameter with that, and that may be useful for like maybe you are making a shooter and you have a bullet system, and whenever your bullets collide with something, then you want to send a message to whatever you hit saying, I collided with you, and maybe that'll have something to respond, maybe it won't. But you can make sure that if it does, then it will be heard. And some uses of like the more basic stuff, like the more basic integrated Unity messages, is you may want to use awake to spawn enemies before the game starts. You may want to use update to check for player input, as I mentioned earlier. And you can use onDestroy to clean up parts of your code just so you won't get any errors. Like make sure that some references are unset and nothing that doesn't exist won't be called. Do we have any questions about messages?
How do you trigger custom messages? You just like call them like a method like dot.
Almost. It's kind of like that. But, excuse me. So the way that you'll be doing it is, imagine you just have like a normal function in C# or like maybe think Java or something like that. So I'll say that I have public void take damage. What you could do is you could just call that function just flat out using a reference to it, but messages are specifically meant to be used whenever you don't have a reference to it. So instead, you would get a game object. I'm gonna go back to my bullet point here. I'm going to imagine in my head that we have a bullet firing system that uses a raycast. So it just points a line from the player camera outwards and sees like, okay, what do we collide with? And whenever we find out what we collide with, then I will get the game object of that, because that's a part of Unity. It will tell you, like if you had a raycast hit something, it'll give you the game object that it hit. I will get that game object and I will send it a message saying, take damage. And what it's going to do is it's going to look through its components and it's going to see, do I have a function called take damage? And if I don't, then it won't do anything. But if I do, then it will tell it to take damage. It's basically calling functions whenever you don't have a reference to that actual class. That's what it's used for. Do we have any others?
Just a really random question I had. This is Unity, right? So I know Unreal was made by Epic Games, right?
Mm-hmm.
So it's like, how does it work? Like, do they take part of like the money you make?
That's actually a really good question. So, at least how I'm familiar with it, and I know that like they've been changing some stuff recently, and I'm not exactly sure like what their new policy is, but a lot of companies will pivot towards Unity instead of Unreal because their pricing is flat. It's not percentage based. Unreal, if I recall correctly, they take 5% of your profits after you break $1 million, which is generous, but for a big company, like 5% is a lot, and they're going to be cracking $1 million. So a lot of companies will opt to use Unity instead because the rate is flat. Whenever you reach a certain price threshold or a certain like revenue threshold in Unity, I want to say it's $200,000. Then all they make you do is buy a subscription to Unity Pro. It's like it's either a monthly or an annual fee. It's like maybe $1,000, something like that. And that's only if you do break, let's say 200,000. So if you break 200,000, you need to pay a subscription to Unity Pro, which will also actually unlock you new features. So I don't use it because it's expensive and I don't need to. But whenever you do get to that point, you're not going to be paying a cut of your profits. You're just going to be paying for that subscription. Any other questions? All right. So the next steps in terms of getting started with Unity or maybe wanting to make something would be, I would say, look up a YouTube tutorial for a game that you want to make. The way that I got into this was I wanted to make a turn-based game, so I looked up a tutorial of how do I make a turn-based game in Unity. 5 years later, this is my job now, so that is an amazing place to start. Use it as a resource. Basically, any game idea that you have, any genre you may want to break into, someone's already telling you how to do it. You just got to go find them. And if you have a specific problem while you're developing, you encounter some sort of issue or you don't know how to implement something or you're just having some sort of problem, then ask the Unity forums because, as I said, this engine has been around since 2005. That's 20 years, and there are hundreds of thousands of users. The Unity forums are so active, and I have found answers to such specific questions, it is actually mind-boggling sometimes. I would never imagine in a million years someone is having the exact same issue that I'm having while I'm going down my development route, but I look it up on the Unity forums and someone from 2014 already answered it. And if you don't have an answer, be the first to ask the question, and someone will provide it. And you'll probably help other developers too who are looking up your same problem. And that is the end of my intro to Unity. So, thank you.
We might go back to the QR slide.
Of course.
I forgot to tell you that I changed the Discord to the attendance QR code, just so I can get
Gotcha.
an idea of how many people are just in all these things. Just ended early there, so if you have any questions, feel free to come up to me or Glenn and ask them.
Do you like me to stop the recording? Do you like me to stop the recording?
Oh yeah, stop it.
All right.
I have a question about graphics and like